Hello, this is Mr. Stewart bringing you the 7.3 homework quiz all about triangle classifications. Be aware there is a possibility that you'll see 3 different 7.3 quizzes, all of them about triangles, but this one's just focused specifically on classifying triangles, meaning giving them names and titles based on their properties of angles and side lengths. The other 2 are about the interior angles of triangles or the side lengths of them, but more specifics about them. So let's dive right into the test and just see what's happening here. 4 different questions. The first one reads, select all the triangle classification titles that do not exist. Okay. Now, there are several different kinds of triangle classifications, and we do need to talk about how we classify those triangles. But just to make sure you understand, select all that apply. So if there's a triangle classification that just does not exist, that's the one you're going to click on. Leave everything else blank. So you may select more than one, so it could be this one, this one, and this one, or it could be this one, this one, this one. I don't know. Like, we'll just have to look at it and see. Okay. Now, to emphasize this, I'm actually going to leave the quiz for just a second. I'm going to show you the exact image that came from your 7.3 discussion. So students, if you are struggling with the 7.3 quiz right now, there's a very good chance you didn't watch the 7.3 discussion, the video of which taught exactly how to classify triangles. In addition to that, this is also what I did in class. So what you're seeing is a lecture that I've prepared for my students that I've already taught in class. You've probably already wrote these down in your notes somewhere. So if you are struggling with this, then there's a very good chance that you are not doing what's required of you to just be a learner in the first place. That being said, push that aside. Let's just talk about, we classify triangles using, first of all, their angles, and second of all, their side lengths. So to understand what I mean by that, let's just take a look right at one of these triangles. What you have here is a triangle whose angles are all less than 90 degrees. Now, when I say an acute angle, I want you to think, okay, that's something that's smaller than 90 degrees. This angle is smaller than 90 degrees. And acute triangles are special kinds of triangles that have all three angles are acute, meaning all 3 of them are less than 90 degrees. So we call this an acute triangle. Okay? Now, that's its first name. So it's an acute triangle. Sure, we can call it an acute triangle, but we can also call it by its last name, or how we measure the side lengths. So a triangle whose side lengths are all 3 different, we call this a scalene triangle. Let me show you what I mean. So if I were to take a ruler and measure this side length, and then I would take a ruler and measure this side length, and then take a ruler and measure this side length, all 3 would come out to be different numbers. So a triangle is classified by its side lengths and by its angles, and we put them together. We would call this an acute scalene triangle. And it's a specific kind of acute triangle. It's a specific kind of scalene. Together, it's an acute scalene. So it's not just an acute triangle. It's not just a scalene. It's an acute scalene. Let's take a look at the next one here. This one's called an isosceles acute. And the reason we call this an acute, same idea. It's an acute, meaning all angles are smaller than 90. But here's the interesting thing about isosceles. Isosceles triangles are triangles whose, we would say, 2 side lengths equal. 2 of the side lengths are equal to each other. So, an example, this side length is the same as this. If I were to measure them, they would come out to be the same length. And this third length here is not the same as the other two, and that's important to understand. This is exactly two side lengths that are equal to each other. This is what we call an isosceles triangle. So it's not just an isosceles triangle, it's an isosceles acute triangle. Now, you can say it acute isosceles, or you can say it isosceles acute. It doesn't matter either way, but that's what we call an isosceles acute triangle. It's both of them. Let's take a look at an equilateral triangle here. And equilateral triangles are special kinds of triangles as well. They are definitely classified as acute. They are acute because all three angles are smaller than 90 degrees, but the name implies something very special about this triangle. Equilateral triangles have all three side lengths and all three angles the same, equal to each other. So the angles are all equal to each other and the side lengths are all equal to each other. We can go even further than that and say, I know exactly how much these angles are worth. Every equilateral triangle will always produce angles at 60, 60, 60. The reason why that's true, and we'll get into this in a later discussion, but the reason why that's true is because the sum of the interior angles of any triangle, every triangle, always comes out to be 180 degrees. And if you have an equilateral triangle, and those angles must come out to be 180 degrees, so you're basically splitting 8 into 3 equal parts. Then it comes out to 60. So that's why these are equilateral triangles. I did forget to mention that isosceles triangles have two side lengths that are the same, but they also have two exact angles that are the same. So this angle is different than these two down here. These are the same. As well as that side length is different than these side lengths up here that are the same. So that's important to understand. So if a triangle has two side lengths that are the same, then they're also going to have two angles that are the same. And I'll mention this under the scaling because, again, I forgot. Each side length was different, which also implies that each angle was different. Okay, so all of those angles are different. This is what we call a scaling. Okay, so we've now covered a scalene acute, an acute scalene, an acute isosceles, and an acute equilateral. A lot of people just call this an equilateral triangle without saying it's an acute equilateral, but it's an acute equilateral nonetheless. Let's move on to the next set of triangles. I'm going to now move these just right here, and I'm going to stop here and just leave that right there. So a right triangle is a triangle that has exactly one angle that's equal to 90 degrees. One angle that's equal to 90 degrees. The reason they can only be one is because a triangle couldn't have more than one 90-degree angle, because that would take you above and beyond 180 degrees. So if a triangle has exactly one right angle, it's automatically called a right triangle. And this one happens to be a right scalene because it has three side lengths that are different, as well as three angles that are different from one another. So a right scalene triangle is a triangle with one 90-degree angle and the other two angles different from one another, and all three side lengths different. Let's move on to the isosceles right triangle. So again, it's a right triangle because it has exactly one 90-degree angle. That's good. And these angles here have something in common. They are equal to one another. So an isosceles, remember isosceles just means that two are the same. Two. And the way you can memorize this is I saw with my two eyes. If you have two eyes, you see with your two eyes. And isosceles has exactly two of the same of something. So just it's kind of a way to memorize it, just a little gimmick. Now, isosceles right triangles are special kinds of triangles as well. Because I know that the sum of the interior angles of a triangle always come out to be 180 degrees, and I know that one of them is 90, that leaves me 90 degrees left to be distributed between this angle and this angle. But I know that this angle and this angle are equal to one another. So I have to split this into two equal parts, which means each one is going to come out to be 45 degrees. So an isosceles right triangle is always going to have 90, 45, 45 degree angles. Regardless of its size, you can stretch it, make it bigger, its side lengths can increase, it can get smaller, but the angles within them will always be 90, 45, 45. The other way to think about this, let me just erase this real fast. The other way to think about this triangle, again, it's a special kind of triangle, and it's basically, it's exactly half of a square. It's a square cut in half diagonally. So you can think of that as well. A square whose right angles are all 90 degrees. So if you're cutting one of those right angles in half, you're going to have 90, 45, 45, and that's another way to look at it. Now, we get to the final one under right, and you might be thinking, well, what does a right equilateral triangle look like? And the important thing to remember is equilateral triangles are triangles whose side lengths and angles are all equal to one another. So if you were to try to draw a right triangle that's also equilateral, what would happen is, well, its angles would have to be the same. So that's an angle that's 90 and that's an angle that's 90. And at this point I've got three sides, and I could create a third angle here, and that's okay, but this is no longer a triangle. So a right equilateral triangle does not exist. It just doesn't exist in our world of geometry. Right equilateral triangle is essentially a square, which is not a triangle, and its sum is definitely more than 180 degrees of the interior angles of the triangle. So there are all of your right triangle classifications. There are only two of them. You only have a right scalene or a right isosceles, but no such thing as a right equilateral. The last group at this point is going to be, this is pretty much everything about the quiz. So if you have this instruction down, the quiz is going to take care of itself, and we'll quickly go over them, but I'm not going to do much more with it. Obtuse triangles have exactly one angle that's larger than 90 degrees, and only one. And the point of that is it's kind of the same. The sum of the interior angles of triangles must always be equal to 180 degrees. As soon as you have an angle that's larger than 90, then no other angle can be larger than 90, otherwise its sum will be larger than 180. So if this is larger than 90, these other two must be acute. Okay? And so you've got an obtuse scalene, which is literally just an angle, a triangle with an angle larger than 90 degrees, and its side lengths are all different. We talked about the scalene acutes and the scalene right, so that's now just an obtuse scalene. Okay, and let's move on to the next one. We've got an obtuse isosceles. This is again one angle whose length or whose rotation is larger than 90 degrees, and two other angles that are acute. So you got the one, as long as it has just one angle that's obtuse, it's automatically an obtuse triangle. And isosceles are this idea that two side lengths are the same and one different, as well as two angles are the same and one different. So I saw with my two eyes, think of two. Okay. Finally, you get to the obtuse equilateral, and again, darn it all, it just doesn't exist. Again, like, try to create a triangle that has equal. Try to create an obtuse triangle with three equal lengths and three equal angles. and you would be right in saying that doesn't exist. Because as soon as I try it, I mean, it's just, there's no way I can join this third side to this third side without creating something that's not a triangle. So an obtuse equilateral triangle does not exist. Now let's go back to the quiz. That should answer question number 1 for you. It's a very long explanation, but if you understand that, then this question should be fairly easy. Question number 2 is just asking you to classify, just like I did, each one of these. So triangles, all 3 angles that are smaller than 90, what's it called? And by the way, let me just show you something. There's no need to ever worry about typing it correctly. Make sure you just click on the space, and you can click right in here on the word bank, and it will put the answer in that space for you. Okay, so whenever you're clicking on each one of the spaces, just use the word bank, and it'll just put it right in there for you. That's really nice. So again, use your knowledge of triangle classifications by their angles and by their side lengths to put in the correct answers here. Okay. Now, this one requires you to match up what you see. So you observe the triangle, and then you say, okay, is it an obtuse scalene, an acute isosceles, an obtuse isosceles, an acute scalene, a right isosceles, an acute equilateral, a right scalene? It's one of those 7, okay? And how this works, and be cautious with this, you type in just the letter that it corresponds with. Okay, and it'll do a matching. Now, you could have more than one triangle be the same answer. Just be cautious of that, be aware of that. And you may have answers over here that don't have anything matching up with any of these 4 triangles. So don't think that every match should have something, or that if just because I've used it once doesn't mean I can't use it again. But there you go. Again, if you're not sure how to answer this question, I would go back to the first of this video. Like the first 12 minutes is all about how to classify these triangles. Last one, it's the same idea, classifying triangles based on their given angles or side lengths. So I'll just give you just a quick little warning on this one. Same idea, but this time instead of showing you a picture, I'm just showing you the angles. So this is a triangle that's a 90, 45, 45. So is it a right isosceles, right scalene, acute isosceles, obtuse scalene, acute equilateral, acute scalene, or an obtuse isosceles? Go back and review your notes. What is a triangle that has one 90-degree angle and 2 other angles that are the same? What do we call that? Okay. What's a triangle that has one 90-degree angle and all 3 angles and side lengths different? What's a triangle that has one obtuse angle and 2 other angles that are different? What's a triangle that has one obtuse angle and 3 other angles different? And this one, by the way, this is side length. So what's a triangle that has a side length of 8, 8, and 8? What do we call a triangle whose side lengths are all the same? Hopefully this video was helpful for you. Not a lot of I shouldn't say not a lot of solving in this one. It's more like, do you understand how do we title the triangles? But it'll be important for future classes and for future math stuff. So make sure you understand how to classify triangles, and we'll get more into depth about the properties of the angles and side lengths of triangles in the next few quizzes. Have a good day.